Hello, good morning. Today's video is going to be on the reduction of multiple subsystems. And before we do that, I'd like to brush over some things first. So, from class, you are aware of the summing junction, right? That if you have two signals coming in from this side and that side, plus and plus, let's see, signal A and then signal B, the output is going to be A plus B. Likewise too, if you have a summing junction where this is plus and minus, A and B, the output is going to be A minus B, right? And then you also spoke about the fact that if you have three signals coming into a summing junction, right, you can decompose the summing junction into two summing junctions. So let's say this is signal A, B, and C, and then they are all summing up, right? You can break this down into two summing junctions. So you have this plus and plus, this is signal B, this is signal A, and then this then is signal A plus and plus. And this gives you A plus B plus C. Likewise to the output of here will be A plus B plus C, right? Just make sure that the sign here is the same as the sign here, because you don't want to have a plus here and then a minus here to make the whole thing conformed. Now, I could also say the same thing too if I have a pick-off point, right? So a pick-off point is just a pick-off point like this, where if I have signal A here, then the same signal is going to be here and then here, right? Wait. And I could also write it in such a way that if I have it like this and I have signal B, this is my pick-off point. So the signal here, here, and here are all the same. I have B, D, and B. So this is a pick-off point, right? Yes. So let's move on to how to identify or how to break down multiple subsystems. Now, before we move on to that, I'd like for you to recognize some forms that these subsystems come into. So the first one is it could come as the cascaded system or the cascaded form. The cascaded form, where if you have a block or blocks with a transfer function G1, G2, and G3, let me add S, and then you have a signal coming in like this, and then these are all interconnected in a way. And there's the input and that's the output. So this is in a cascaded form. So to find the transfer function of this cascaded system, it's simple, right? It's going to be R output over input. Then I find the product of the transfer functions, right? So it's going to be G1 of S multiplied by G2 of S multiplied by G3 of S. This is the first form that you can actually have one. Now the second form is the parallel form. For the parallel form, it involves a summing junction. So if I have a summing junction here, it's just like what we just did, right? And then you have a block of transfer function g1 of s, another block of transfer function g2 of s, and then another block of transfer function g3 of s, right? And they are all going into the summing junction. They're all going into the summing junction, plus, plus, and plus. And then you have a signal here, let's call it A, another signal here, B, and another signal here, C. To find the output of this side, or to find the resultant of the summing junction here, there's going to be the transfer function, the A times the transfer function here, which is going to give me the signal over here. So the signal over here is the signal over here is going to be A Gen1 of S, right? And that over here is going to be B Gen2 of S. And that over here is going to be C Gen3 of S. So these are the signals coming to add up at the summing junction. So I'm going to get A Gen1 of S plus B Gen2 of S plus C Gen3 of S. Now if here were to be minus, if this side were to be minus, then this whole thing changes to be minus, minus, and minus. Then I have to change this thing, the sign here, to minus. So I get here to be minus, minus, and minus, right? That's the parallel form. Now the third form is the feedback form. The feedback form. So for the feedback form is a combination of the pickoff point and then the summing junction. So we have a summing junction here. A signal is coming in from this side. Let's call it R of S. And then it moves into a transfer function, or a block of transfer function G1 of S. Then the output is C of S. Then there's a pickoff point here, and then it also moves into a block of transfer function CH1 of S. Then it comes back into the summing junction, right? So you have a feedback form right here, and let's say this is plus and this is minus. So to find the transfer function of this whole thing is going to be C of S over R of S is equal to Gen1 of S all over 1 plus Gen1 of S H1 of S. There's a way to prove all of this, and I'm sure you've already done it in class, so there's no need for me to go through again. Now it's plus here because of the minus here. So if we want to change, so if let's say this is plus, then this has to change to minus, right? So let me kindly draw it again. Plus, and then plus, and R of S, C of S. So it's going to be C of S, R of S is equal to Gen1 of S over 1 minus J1 of S, H1 of S. Right, so this is how it's going to be like. So the sign here is dependent on what the feedback path is, So if the feedback path is subtracting from the summing junction, then your sign here should be plus. If it's adding to the summing junction, then it should be minus. Right? And the next thing that I'd like for us to talk about is the movement of the summing junctions. So if I want to move a summing junction ahead or behind of a block, what should it look like, right? So let me just divide this side. Okay. So if I have a block of summing junction of a block of transfer function, so block of transfer function J1 of S, right? And then I have a pick-off point here. Let's see, here is A, here is A. Or let's forget about the signals for now, because I want to make a point. Okay. Now, if I want to move this pick-off point right here ahead of this block, what should it look like? Okay. And you've already done this in class already, so I'm not going to like go through. But for the sake of people who weren't in class or something, let me just go over. So you have a signal here A, and then due to the pick-off point, the signal here too is also the same, right? So the output here is going to be A J1 of S, right? Now if I should move this pick-off point to this side, what should it be? I've moved this pick-off point this side, and then the signal here is still A, and the transfer function here is still J1 of A. Then the output here is still A J1 of S, right? But then the signal here is A, then I want this signal here to also be A. So what changes should I also do to this to make the output here, the signal here A, and then the signal here to A? Or like I want to make the output here the same as the output that we had before. What then should I do? The trick is, if you look closely, we can add the inverse of the transfer function over here, right? So you can see that to make it look the same thing, I can inverse the transfer function of that block over here, and then it will make perfect sense to if I do that, because the signal here is A J1 of S, right? If I should multiply this A J1 of S by the inverse J1 of S, this cancels this, then I get the A back, right? Makes perfect sense, right? Wait. Now the second scenario where I'd want to move J1 of S, I'd want to move a pick-off point behind a block of summing junction. So what happens if I want to move a pick-off point behind a block of transfer function G1 of S, right? So here is A, and then the output here is A J1 of S. Then the output here, the signal here too is also A J1 of S, right? And I want to move this pick-off point behind this block of transfer function J1 of S, right? So likewise too, we are going to do the same thing that we did over here. So I'll draw it, then I'll move it behind J1 of S. This is my signal A, this is my signal A J1 of S. And then I still want the same signal A J1 of S to be here, right? And it's not possible because for the laws of pick-off points, the signal is supposed to be the same, right? If I have A, here, then I should have A here, but then that's not the case. So it means that we have to modify this branch over here. And then the only way to do it is that we have to multiply this A by J to get the signal A1 of A, G1 of S here. So the change that we have to make here is you have to include another block, right? J1 of S to get this right here, right? So this is the second scenario. The first scenario was if we want to move a pickoff point ahead of a block with a transfer function J1 of S, then we have to inverse that transfer function, right? And then multiply with the signal. Now the second scenario was if I want to move a pickoff point behind a block with transfer function G1 of S, then I'd have to multiply that signal with the same transfer function to make the whole thing balance. Now, what if it's a summing junction? So the third scenario is what if I want to move a summing junction ahead of a block or behind a block? What then should I do? So let's draw. I have a summing junction here, and then I have a signal A and then B. They are all summing up here. Then the output is going through a transfer function G1 of S, right? So the output here is going to be J1. Let's forget about the of S there for some time now. It's going to be A J1 of S multiplied by A plus B, which is the same as J1A plus J1B. Now I want to move this summing junction ahead of this block. What should I then do? Let's say I've moved it right here. There's J1, this is my signal A, and I've moved this summing block ahead of here. And I still want my output to still be the J1 multiplied by A plus B, which is the same as J1 A plus J1B. Right. Let me clean it and write it first. Okay. I still want my output to be J1A plus J1B, right? I should have used red pen, by using something you can see it now. Okay. So what then do I do? Now if you look closely, we have A multiplied by J1 is the signal over here, right? A multiplied by J1 is the signal over here. So the signal over here is A J1, right? So if I want to get the same output here, then I have to add J1 of B, or J1 multiplied by B. So I'm adding here and I'm adding there. So then I have to add the transfer function right here, J1, and then this is my B. Right, then I balance everything up, right? Because the signal here would be J1 of B, right? So when I add this and this, it gives me this. So the third scenario is that if I want to move a summing junction ahead of a block with a transfer function J1 of S, then I have to multiply the second signal, in this case is B, with the transfer function to actually make the whole thing balanced, right? Now the fourth scenario is if I want to move a summing junction behind a block of transfer function G1 of S. So I have a block here G1, and then a transfer function here. So a summing junction, I don't know why I keep on saying transfer function. So a summing junction here, and then the signal here is, let's say, B, and I have A here. They are all adding B. So what would this output be? The signal here is going to be A times J1. So I have A J1 here, right? When I add this A times J1 to B, I'm going to get A J1 plus B, right? Now I want to get the same thing when I shift, or when I move the summing junction behind of this block. So I should get we draw the whole thing again, and then we shift it. Okay. This is A, and then yeah, we expect the output to be the same thing, right? Of J1 plus B. So what then do we do? To do this, we have to multiply the second signal, in this case is B, by the inverse of the transfer function over here, right? So if we do that, then we are going to get the signal here to be, mind you, this is adding, right? If we do that, then the signal here is going to be A plus B1 over G1, right? And then there's a signal here. So to find the output is going to be this signal multiplying this G1 over here. So I get the output with G1 multiplying A plus B over G1. When I expand, it gives me A J1 plus B, which is the same as what we have here. Now you can fast forward it if you already know this. You can fast forward it. So this is how it is. But then to make it easy for you to remember, this is how I used to remember the whole thing. Right? So if I have a little table that I draw here, this side is P, S, A, and then B, where P stands for pick-off point, S stands for summing junction, the A stands for ahead, and then the B stands for behind. Now what's going to go into this side here, right? So what will go into these portholes here are going to be either I, which stands for inverse, or D and I, which stands for do not inverse. Right? It's actually simple for me to remember this way. So from what you've done so far, if I want to move a pick-off point ahead of a transfer function, ahead of a block with transfer function G1, then I have to inverse that transfer function, right? So it's like this. So if I want to move a pick-off point, ahead of a block with transfer function G1, then I have to inverse that transfer function. Likewise too, if I want to move a pick-off point behind a block with a transfer function G1, then I do not inverse that transfer function. So you can see clearly here that We are trying to move this pickoff point behind this transfer function, this block of transfer function G1. So we do not inverse that transfer function. So we just multiply it like that. Now the third one is, if I want to move a summing junction ahead of a block with a transfer function G1, then I do not inverse that transfer function. I can show you here that we are trying to move this summing junction ahead of this block. So we do not inverse that transfer function, right? That's what we have here. If I want to move the summing junction behind a block with a transfer function G1, then I have to inverse that transfer function. And that's what we've done here. So I'm trying to move this summing junction behind this block. So then I have to inverse that transfer function of that block, right, to actually make things balance on this side. So this is what I use to make things easy for me to remember. So you can just draw it, and then name it P, S, A, B, I, D, N, I, D, N, and I, because it makes everything simple for you to remember. Okay, wait. And then I like to also talk about something. If you have a transfer function like this, so a block with transfer function G1, you have R of S. It means that since there's a pickoff point, then the signals here are all going to be the same thing. So they are going to be R of S multiplied by J1 of S. And then here too is the same thing, R of S, J1 of S, R of S, J1 of S, right? I can also write it this way. With the block here, J1 of S. Let me clean this side. J1 of S, J1 of S. Here is the signal R of S. And then it's going to be the same thing. J1 of S, R of S, J1 of S, R of S, J1 of S, right? It's actually the same thing that I've written. Now, if I have a pickoff point too, let me illustrate this on a different way. So if I have a pickoff point too like this, J2 of S, right? I can also write it this way. Can split it in this form. Right, it's agreed, right? Can actually do it this way. So keep these in mind, especially these two in mind, because when you are solving the questions, you are going to need them to actually make our life simple. So let's pick the first question and solve. So you are supposed to reduce this transfer function into its simplest form, right? So based on the forms that we've seen so far, we said it comes in three forms. The first one is the cascaded form. The second one is the parallel form. and then the third one is a feedback form. So based on the things we've seen so far, if I should look at this block diagram right here, can see that this transfer function or this block and this block are in cascaded, right? Okay, great. Likewise too, based on what I've seen so far, this is going into the same direction, into a summing junction. This one too is going into a summing junction, right? And they all have the same direction. Then I can see that this system right here is in a parallel form, right? Okay, great. If I do that, so let's see if we are able to reduce this whole thing into a single block, then I can see that this and what we've reduced here are in the feedback form, right? So let's solve the question and let's see what I'm talking about. I'm sure you solved this question before, so you see it's very simple. Okay. So like I said, if I want to redraw this system, the thing is lagging. Since these two are cascaded, since this and this are cascaded, I can find a product, right? So s times s is going to give me s squared. Then it moves on to this summing junction plus, and then there's a pick off point here. S also moves into plus one over s over s. And there's a feedback right here. Okay. Transfer function R of s. Now I've been able to reduce these blocks here into a single block right here. Now, like I said, the thing is lagging. Okay, like I said, this and then this are in a parallel form, right? So then I can add them into a single block. So I can do it this way. I'm going to clean and write a lot. So I can add these two to give me this to be s squared plus 1 over s. Right, understood? Let me draw because I feel like if I'm cleaning, you wouldn't see what exactly I'm talking about. So let me keep on drawing. So I have a transfer function s squared, and then there's a summing junction here plus one over s plus. Okay, let me draw over again. So I said that this and this are in a parallel form, so then I can add them because there are plus, there's a plus here and then there's a plus here. So if I'm to redraw this side again, it's going to be just s squared plus 1 over s. 1 over s. There's a feedback right here. Plus minus s. And then c of s. Right. Now we've been able to reduce this to give us this. Right. Now the next thing to reduce is, can see there's a feedback form right here. Right, there's a feedback form right here. Right. Right, it makes sense. So if there's a feedback form right there, then I can redraw this thing to give me so remember what we said here about the fact that I can decompose the summing junction to give us something like this, right? So we are going to use it the same over here. Can decompose this summing junction right here, right? So let me decompose it. I'll get r of s plus and minus, this one comes here, s squared plus 1 over s this s, then it goes on. So I've decomposed the summing junction here into two summing junctions, and here is plus and here is plus. Let me see if the question said plus. Yes. So here is minus rather. Here is minus. So I can see that I have a feedback form right here. Right. This whole thing is a feedback form. Right. And then since like it doesn't matter where this one is, it can be down here, it could have been down here too. So it will all be the same. So the transfer function, now there's no block here, right? So it means that the transfer function of this feedback part here is 1. So if we want to say, or if we want to find the transfer function of this feedback form right here, is going to be this is my g, right? So it's going to be s squared plus 1 over s. 1, because there's minus here, is going to be plus, then s squared plus 1 over s multiplied by the transfer function here, which is 1, multiplied by 1. Right? So then I can reduce this whole thing and then draw another block with the transfer function this. Okay, so it's going to give me this way, r of s plus minus, then I draw another one. This time the transfer function is s squared plus 1 over s all over 1 plus s squared plus 1 over s multiplied by 1. Then it goes into this 1 over s and c of s. Then there's a feedback right here of s. Okay. Now I'm getting something nice, right? So can see that this block in this block 2 are cascaded, so I can find the product. Okay, great. Now I can, so now that we've reached there, we can combine, or we can merge these two blocks. Can merge these two blocks into one. So if I should merge them, I get plus and then minus, then I merge the two. That gives me s squared plus 1 over s multiplied by 1 over s all over 1 plus s squared plus 1 over s, multiplied by the 1. Then I get a feedback, which is s, which has a transfer function of s. Then it goes back here. Okay. Now, based on what you've seen so far, if you have, here is g, and then this side is h, plus minus r of s, c of s. And I can see that the transfer function of this whole block is going to be g1 plus gh. It's plus a because of the minus here. 1 plus gh. Now by comparison, I can see that my g here is the same as this whole thing right here. Then my h here is the same as this s right here. Okay. So let's write the overall transfer function of this side. It's going to give me my g here, s squared plus 1 over s, 1 over s, all over 1 plus s squared plus 1 over s multiplied by 1. Okay. All over 1 plus, it's plus here because of the minus here, s squared plus 1 over s multiplied by 1 over s all over 1 plus s squared plus 1 over s multiplied by 1 multiplied by the s, which is s. Now I can write the s here, okay, yeah, which is s. Okay. Now in class it's going to, okay, so you can't just leave your answer like this, especially if the question goes on to ask you find the number of poles, or find the number of find the zeros, or find the poles of the system. You can't leave your solution like this. So in class he said the g, if it's the g is mostly a transfer function, right? And it has a numerator and then a denominator a, and then the h2 likewise a transfer function with the numerator, let's say n sub k, and the denominator d sub k. Now if I substitute these in here, can see that I have n sub a, d sub a all over 1 plus n sub a, d sub a multiplied by n sub k, d sub k. Now I don't want to see any fraction here apart from this one, so I use the crease and destroy thing that we've been talking about. So to get rid of the d sub a, I'd have to create it here and then destroy it here, right? And I want to get the d sub k to like get rid of it here, right? So I create it here, then I destroy it here. So this cancels this, then I get n a d k. 1 times all of this here gives me dA dk plus this dA here cancels the dA here, then I have NA, and then this dk here cancels the dk here, then I have NK, right? So based on what we've seen over here, you can clearly see that this is my G, right? This is my G. And then this is my H, right? So by comparison, you can see that for G, my NA is, because I'm talking about the numerator here, my NA is going to be, my NA is going to be S squared plus 1 over S multiplied by 1 over S. And then my DA is going to be 1 plus S squared plus 1 over S. And then this is multiplied by 1. Just let's keep the 1 there for formalities. And then for the S, my NK is S, and then my DK is 1. So to put it into this formula here, can see that my overall transfer function here is going to be NA. NA is right here. I have S squared plus 1 over S multiplied by 1 over S times my DK, which is 1, all over my DA, which is 1 plus S squared plus 1 over S multiplied by 1 multiplied by my DK, which is 1, plus my NA. My NA is S squared plus 1 over S multiplied by my NK. My NK is here, which is S. So you can see that finally I can cancel, right? This cancels this here, and then I can spread this one out. Let me spread this. 1 over S 1 plus 1 over S, and this gives me S squared plus 1 over S. Now I can multiply through by the 1 over S, right? So it will give me S plus 1 over S squared, and then 1 plus S squared plus 1 over S plus S squared plus 1 over S. Okay. Now I want to get rid of this S squared at the denominator here, right? I don't want to get any fraction apart from the main fraction here, right? So I'd have to create and destroy. So I'll have to create my S squared here and then destroy it here. By doing that, if I should multiply through, I'll get S cubed plus 1 all over 1 times this S squared is S squared here, right? And then this S squared times S squared gives me S raised to the power 4 plus S cancels one of the S's here, then I get S plus S squared times S squared gives me S raised to the power 4 plus one of the S here cancels one of the S's here, then I get S. So if I should group like terms at the denominator, I'll have S squared, S raised to the power 4, S raised to the power 4, 2 raised to the power 4 plus S squared plus 2S. So this is what I'm supposed to get as the overall transfer function, right? If you're okay with this, Then let's move on to the next question. If you are not, then I suggest to rewind and watch the whole thing. And if you still don't understand, then you can come by the TA's office, or if you are in a group studies, you can actually speak with them and then they will take you through some stuff. Okay. So the next question is this one right here. This one, as observed, so this is the next question. We are supposed to find the transfer function C of S of R of S. Okay, so let's see what we have. Maybe we have some familiars that we've seen before. So you can see that this, I think it's lagging right here, is in a parallel form, and then what we have here too, that's in a feedback form, right? And then it's all cascaded with this one. So if you practice more and more, you can actually do away with drawing planes, and you can just use your eyes to actually solve most of the things. So, but for the sake of explaining, let me just keep on drawing and drawing. Okay. So this is parallel, right? So it can see that because it's going in the same direction, and here too is going in the same direction, right? So I can take this right here plus minus R of S 1 over S squared. This is in a feedback form, right? So you can decompose this right here, but I'm sure by now you are masters based on what you've seen, so there's no need for you to actually decompose all of this. So there's a feedback form. This is my G and this is my H. So to compress all of it into a single transfer function, it's going to be my G, which is 50 over S plus 1, all divided by 1 plus, it is plus here because of the minus here. It's plus here because of the minus here. Plus my G, which is 50 over S plus 1, multiplied by my H, which is 2 over S. And then this is also in a parallel form, right? So I can compress it all down to give me the S is going into the positive side, so positive S, and then the 2 is going into the negative side, so minus 2. Then I continue that way. Okay, great. Now I can tell that this block and this block and this block are all in the cascaded form, right? So I can merge them into one single block. So I can write it this way. Merge all of them into one single block by just multiplying them. So I can see 50 over S plus 1 multiplied by 1 over S squared multiplied by S minus 2 all over 1 plus 50 over S plus 1 multiplied by 2 over this. And this gives me that. Minus M plus R of S. this part right here has a transfer function of 1. Exactly, you said it. It has a transfer function of 1. So if I want to write it in this form, I have this G H minus R of S and then C of S. Then the transfer function of this is G over 1 plus GH. Now by comparison, you can tell that the G is all that are fitting over here, right? And then my H is 1. There's nothing over here, or there's 1 here. I don't put it that way. So my transfer function is going to be this whole thing, which is my G, 1 over S squared 50 over S plus 1. Let me write it so. S plus 1, S minus 2, all over 1 plus 50 S plus 1, 2 over S, all over the 1 plus, it is plus here because of the minus here, G. I'm going to write this whole thing here again. So 1 over S squared 50 all over S plus 1, S minus 2, okay, all over 1 plus 15 S plus 1 multiplied by 2 over S multiplied by each, which is 1. Right. Okay. Now this one overall transfer function, but then I can't write it this way. But then we can use what we derived here to help us simplify the whole thing, right? So I said the G here has NA, DA, and then the H here has NK, DK, right? So this can also be represented as, is it NA, DK all over DA, DK plus NA, NK. Let me see if it matches. Yeah, of course it matches. Okay. So my NA, which is the denominator of the G, which is the numerator of the G, so it's 1 over S squared multiplied by 50 over S plus 1 multiplied by S minus 2. And then the denominator of the A is the 1 plus 50 all over S plus 1 multiplied by 2 over S. Okay. And then the N of K, or the N sub K, is the numerator of the transfer function of the feedback, right? And then it's just 1 because there's no block here. And then the denominator of the K2 is still 1. Okay, so then we can do some simple substitution here to get this whole transfer function right here. So my NA is this, right? So I just write it 1 over S squared 50 over S plus 1 S minus 2 multiplied by my dk, which is 1, all over dA times dk. My dA is what I have here, 1 plus 50 over S plus 1 multiplied by 2 over S. That's my d. Now the d sub a is multiplied by dk, and dk is 1 plus na. My na is this right here. So 1 over s squared multiplied by 50 s plus 1 s minus 2, and then the na is multiplied by nk, which is 1. Okay, so now it's simplified in a simplified way. So you can have 1 over s squared 50 s plus 1 s plus 2, and then you have 1 plus 50 s plus 1 multiplied by 2 over s plus 1 over s squared 50 s plus 1 s minus 2. Now I can do some things here, right? I can simplify it. I don't want to see s plus 1 here. I don't want to see s squared or s anywhere. So I can create them and I'll destroy them. So let me start with the s squared. I can create the s squared here. Then I can destroy it. Can create the s squared here. Then I'll destroy it here. Likewise, I can do the same thing to the s plus 1. I'll create it here, then I'll destroy it here. Okay, and then I multiply through. When I multiply through, I get okay. So the s squared here cancels the s squared here, and then the s plus 1 2 here cancels the s plus 1 2 here. So then I get 50 multiplied by s minus 2 all over 1 multiplied by s squared times s plus 1. I get s squared s plus 1 plus the s plus 1 here. I multiply this thing, right, by this whole thing. So the s plus 1 here cancels the s plus 1 there, right? And then the s here cancels one of the s's here. Then I get 50 times 2 is 100. So 100 multiplied by this cancels one of this here, and then s cancels one of the s's here. So I get 100s plus, now come to this thing, s squared cancels the s squared here, s plus 1 cancels the s plus 1 here. So then I get 50 multiplied by s minus 2. Right, everything is starting to make sense. Let me cross check and see if I'm right back. Okay, so let's see. I have 50 s minus 2 s squared plus 100 s plus 50 s minus 100. Okay, I think that's what I was supposed to get. So you can add s minus 2 s cubed plus s squared plus 150 s minus 100. And this is what I was supposed to get for the transfer function over here. And if you feel like this is not what you're supposed to get, just discuss with your friends in your study group, or you can come by the TU's office and let's talk things out. So the third one is a little bit tricky. So based on what you've solved so far, we've not moved any block or anything of such thing. But for this one, to help you practice, we are going to move some things to make things easy for you. So the first thing right here is you have a transfer function here. So sorry, a system here. And then you want to reduce it into the simplest form, right? And it's not anything that you have seen before. Now, some of you may be tempted that this right here looks like a feedback, but then there's a pick-off point here. So this whole thing doesn't qualify to be in a feedback form. Some of you may be tempted to multiply the G1 by the G2, but then that's not the case because of the pick-off point here, right? So it's either you move this pick-off point, this ahead of this block here, or you move this pick-off point here behind this block here. Either way is your choice, but I'm going to try both of them just to make you conversant with how we move, like pick-off points and all of that. Okay, so for the first one, I'm going to move this pick-off point here ahead of this block here. So let's go to our table, right? Our table, let me draw it properly. We have to name this table. We have pick-off points for P, summary junction for S, A for ahead, B for behind. So I want to move this pick-off point here ahead of this block, right? So if I do that, so this block has a transfer function of G1, right? And then based on what we've done, I stands for inverse and DNI stands for do not inverse. Okay, so if I want to move this pick-off point here ahead of this block, right, then pick-off points ahead of this block, then I have to inverse its transfer function. So then I have to inverse this transfer function right here. So I have to redraw the whole thing just to make it clear. Plus G1, right? And there's a pick-off goes into H1, then it comes back minus. Now I've moved this pick-off point ahead of the transfer function here. So if I've moved it according to our table here, we have to inverse this transfer function. So we create another block with the inverse of that transfer function. Then it goes on that way. G3. Now I need you to take your time and pause this video and then just reflect on what I've done here, right? I moved this pick-off point ahead of this block with transfer function G1. I moved it from here to this side, and based on our table, if you want to move a pick-off point P ahead of a transfer function of a block with transfer function G1, then you inverse that transfer function G1. That's what we've done over here. Now everything is starting to make sense, right? We have a feedback form right here, and then we have a parallel form too right here, and so everything is starting to come together. Okay, so I can write this as this is a feedback form, right? This whole thing is a feedback form. You can see that J1 all over 1 plus, it is plus here because the feedback path enters the minus part of the summing junction here, and then G1 H1. Now here is the parallel form, right? So I can merge the two and say that because here is plus and this side is plus, I can say G2 plus, let me write my plus, so plus 1 over G1, then it goes into G3, then you have your C of S. Now this whole thing is in a cascaded form, right? And then what do we do with blocks when their transfer functions are cascaded? We find the product of it, or find the overall transfer function. So it's going to be C of S C of S all over R of S is going to be the product of G1 over 1 plus G1 H1 multiplied by G2 plus 1 over G2 multiplied by G3. Okay, so I can see that J1 over 1 plus J1 H1 multiplied by G2. So this is G1 right here. J1 G2 plus 1 multiplied by 3. So I can merge all of this to give me this cancels this one right here, right? So I can see that I have J1 J2 plus 1 all over G3 1 plus J1 H1. So this is what my whole transfer function is supposed to look like if you are being given a system like this. So the first one is me moving this pickoff point ahead of this block right here. Let's go to the second part. So the second part, I want to move this pickoff point right behind this block and then bring it somewhere over here, right? So based on our table, we can see that if I want to move this pickoff point behind a particular block of transfer function G1, then I have to what? I do not have to inverse that transfer function. Right? So let's draw the block again and let's see. Okay. So I have this is plus, this is minus, then there's an H1 right here. Okay, and then let's go back and see something. Okay, so I'm moving this one right here. G1 G2 and then goes into G3 C of S. Now I've moved the pickoff point from here to this side, right? And then based on our table, it says that we shouldn't inverse this transfer function when you are multiplying with it. So that's what I'm going to do. So we have this right here, and then we are not going to inverse it. Not all. There's nothing here. There's nothing here. Okay. So I have from here to that side. Okay. So that's how it looks like. You have this one right here being moved to this side. So this one it's like I'm moving this block rather ahead of the pickoff point here, which is the same thing. Okay, so now I can see that the G1 and then the H1 are cascaded, and the G1 and then the G2 here are cascaded. So you can further draw it this way. Here's my R of S. You can further draw it this way, that this minus you have G1 H1 G1 G2 plus and then it goes on into a G3 block. Okay, now again I can see that this side and this side are parallel, right? And then this is in feedback. This is in feedback. So I can redraw the whole thing as my main path, or my forward path has a transfer function of 1. So that's my G, like in a way, has a forward function, has a transfer function of 1. So 1 all over 1 plus, it is plus here because of the minus and the feedback path, right? All over my G, which is 1 in this case, 1 multiplied by the feedback transfer function, G1 H1, right? And then this line has a transfer function of 1. Then I'm adding it to the G1 G2 because they are parallel. So I get G1 G2 plus 1. Then this side is still G3, C of S. Okay, now they are cascaded, so I can find the product of the whole thing here, right? So I can say C of S over R of S is equal to 1 over 1 plus G1 H1 multiplied by G1 G2 plus 1 multiplied by G3. So if I should merge them together, I'll get G1 G2 plus 1 G3 all over 1 plus J1 H1. Now you realize that is the same as the one that we had before, right? It's the same as this one. So whichever that you'd go, if you'd want to move this pickoff point ahead or this pickoff point behind, it depends on you. And then most of you are saying that then I'd like to move this one behind this. Like you rather make the whole thing complex. So to make things simpler for you, it's either you move this pickoff point ahead of this block, or this pickoff point behind of this block, just to make things easy for you. Now it's like depends on your judgment for which one you'd want to go and then which one you feel is simple for you. So let's go to the next question. So there's the next question. Okay. So the next question, like always, are trying to find the transfer function U of S all over R of S. So what have we seen before? What's the strategy that we have to use here? can see G1 of S right here. G1 of S. But then because of this and this and this, we can't see that this whole thing is in parallel with this whole thing. So we have to do some manipulations here. What then should we do? And I remember I said something about you decomposing something, right? So I'm sure some of you have seen how like we should go about it to solve this, and you're yelling at your screen and you're saying that it's that simple. Of course, it's that simple. So let's go through some quick thing. We said if you have a summing junction here, here's A, B, and C, right? You can decompose this into this A and C, and then finally get B here, right? We all understand this one, right? Yes, plus 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 and plus and plus and plus C. So now we are going to work in a reverse order, because there's no way that we can see that this is in the feedback transform. It's not actually in the feedback transform, and then here too is not cascaded with the G1 here is not cascaded with the G2 here because of the summing junction over here. So then there's a need for us to actually make some manipulations to see. So I can move this summing junction ahead of this block so that I can join this with this to get a full one right here. So I can it's like I'm working in a reverse form. So I'll move this one ahead of this one right here so that I'll join this and this, right? It's like I'm taking this and this, then I'm getting this one back, right? So that's the course of action. So let's see if to work. Okay, I shouldn't have cleaned it, but I have already done it. Thank you. So let's see if I'm moving in. So before that, let's draw a table here to make us remember things easily. P for pick-off point, S for summing junction, A for ahead, B for behind, I for inverse, D and I for do not inverse, D and I for do not inverse, I for inverse. Okay, so I want to move this summing junction ahead of this block with the transfer function of G2, right? Based on that table here, I'm moving this summing junction as ahead, so I do not have to inverse this transfer function. So let's draw it one more time and let's see something. Okay. I have R of S coming in plus minus. It goes into G1. I'm going to just write G1, and then there's a pick-off point here, and that's G3. So I've moved this summing junction ahead of this G2 block here, right? So then I don't have to like worry about it. Now I have G2 here. Now what I've moved is right here. It's plus and it's minus here. Okay. And then it adds up. Wait. It doesn't add up here. Okay. And then it moves into the second one. Then that's where this comes in. plus, and plus. Okay. Okay. So since we've moved this, like it was once here, but then we moved it here, then it means that we do not inverse the transfer function. So we have G2 here, and then G4 right here. And then this is C of S. And then you have this whole thing coming on right here. Right down. Yeah, okay then. Okay. Okay, this I'm almost done.
Oh no, it is. Oh, it is.
Okay.
Hi.
Hi.
Hello.
Hi.
Yes, so he's having a revision class for, he's a teaching assistant, so he's having a revision class for students. So it's off, this one is offline, so we are recording it, then later we'll upload it. Thank you.
You're welcome.
If that's you.
Yeah, if there's similar
Yeah,
class, then we can get all.
Yeah.
Okay, let's continue. Okay. So now we have a cascaded form here. And it's starting to look like something we've seen before, right? Yes. Now we can exchange this, and it's all the same thing. G1, G2, G3, then I can write this right here. Oh. Now in class, you must know that he said if you have two summary junctions, you can actually interchange their positions, right? So that's what I've done here. If you're paying attention in class, you must have heard that if you have two two summary junctions, you can interchange their positions and then it won't affect anything, right? So that's the same thing I've done here. So I've interchanged the like the position of this to actually give me this. I hope I'm not confusing you though. Yes, so that's why I said I should have said this in the prerequisite, like when I was starting this video, but then I forgot. But if you have two summary junctions, you can actually interchange them, and then it wouldn't affect anything, right? Okay. Now I'm seeing that this is giving me the parallel form, this right here, and then this right here is giving me the feedback form, right? So I can write it to be this way. This is my R of S. R of S. This. I can sum them up. To be G1, G2 plus G3. Then there's a feedback form, right? I can write this to in such a way that this is the main part or the forward part, and it has a transfer function of 1. And there's the feedback part, and it has a transfer function of G2, G1, G2, G4. So it's going to give me 1 all over 1 plus G. So the forward transfer function, which is 1, multiplied by G2, G4. And then the whole thing has a feedback. And it's in plus. Okay, with C of S. So this is in a cascaded form. So I can redraw it to give me G1, G2 plus G3 all over 1 plus G2, G4. And this is in the reverse. Okay. Now, this thing we are familiar with it, right? Okay. So C of S, that's the main transfer function, is going to be this my G, right? Or this is my forward transfer function of G1, G2 plus G3 all over 1 plus G2, G4 all over 1. It's plus here because of the minus here. G1, G2 plus G3 all over 1 plus G2, G4 multiplied by the H, which in this case is 1. Now I don't want to have the 1 plus G2, G4 here. The main fraction I want to have is this one, right? So I'd have to create and destroy. So I create the 1 plus G2, G4 here, and then I destroy it here. 1 plus G2, G4 here. So that when I multiply, or when the 1 plus G2, G4 cancels this 1 plus G2, G4, then this one too cancels this one here. So let's expand and see. I'll have G1, G2 plus G3 all over 1 multiplied by this gives me 1 plus G2, G4 plus this cancels this right here. I have G1, G2 plus G3, and that's it for me. And if you feel like you can break this whole thing down using the method that using any other method but the method that I just illustrated here. You can actually, come by the TA's office and show me how you did it. Yeah, so I'd love to actually see how you did it. Yes. That's it. I would have solved the next question, but it seems like where I am, they are trying to sack me. So maybe next time. But you try and see if you can solve this. So C of S over R of S. You are breaking this down into a single block to find the main transfer function of this. And then see if you can do likewise too for this. Okay. Now for this one, I said let me just give you a gist of how it's supposed to be. If you remember the first part or the introductory part of this lesson, I mentioned that if you have a pick-off point, if you have G1 and then there are pick-off points here, right? And here is, let's say, R of S, G1 of S. Then the signals here are going to be the same of R of S, G1 of S, R of S, G1 of S, R of S, G1 of S, right? I can write it the same way. I can write it as this, then it gives me this the same, and that, where here is R of S, and there's a pick-off point, and then here is G1 of S, G2 of S, and G3 of S. So if I do that, then I get the same thing, R of S, because the signal here is the same as R of S, so it multiplies the transfer function to give you G1 R of S. Here too, the same way. So forget I said G2 and G3 here, they are all the same thing. So you get R of S, G1 of S, R of S, G1 of S. You actually get the same thing. So that's the same principle that we are going to use at this part right here. So don't get confused. Let me just draw it for you and to see how simple it is. So when you have this part right here, right, it's G3 of S, and then it's split into 2, right? So you can write it as one form comes here, and then you have G3 of S, and then you have G3 of S. Okay. Now, again, if you remember, I said if you have this pick-off point right here, and it's G, here is G1, and here is G2, you can actually split it this form or split it this way. Here is G2, and this gives you G3. So the same, right? So see the side right here, right? Let's say let me continue drawing this one and continue drawing this one. I can split what I have here, right? So I have this, and I have that 3. I can write this as this, G of 3 of S, and that G goes on this way. So you saw the same thing. So how you could write this, just this form right here, you can actually write it this way, right? And then you solve it. Okay. So for the sake of simplicity, let me give you the answer of what I had, so that if it will be simple for you. Oh. Okay, yes, I have it here. So this is what I had. Maybe you can simplify it down or something like that. Harvest. Right. And then you saw I'm continuing here. So G3 plus G4 multiplied by, and then G7. So you can break this thing down, and then you actually get what you're looking for. So until next time, bye.